In the world of elite racing, there's really only one thing that matters: speed. But what happens when that obsession with performance slams head-on into the need for sustainability? Well, today we're diving into an incredible story that tackles that exact question, using one of the fastest, most extreme sailboats on the entire planet. Okay, so let's just get right into it. Can elite racing actually be eco-friendly? For a long time, the answer was pretty much no way. See, faster, lighter, and stronger always meant using more advanced materials, and that usually meant materials that were pretty tough on the environment. But a team of students looked at that and said, we think we can do better. So to really get what they were up against, we need to talk about the materials themselves. In the world of high-performance everything, one material has been the undisputed king for decades. But as you can probably guess, that dominance comes with a pretty big catch. And this slide just lays out the whole dilemma perfectly. On one side, you've got carbon fiber, the champion. It's what you find in Formula One cars, in cutting-edge airplanes, and of course, in racing yachts. But then, on the other side, we have our challenger, flax fiber. It's a composite made from a plant, it's renewable, and it takes way less energy to produce. It's got decent mechanical properties for sure, but the big question has always been hanging right there in the air. Is it actually fast enough to compete when every single millisecond counts? All right, so you've got this cool new challenger material, but how do you prove it's the real deal? This is where things get really interesting. To truly test the limits of something new, you can't just run a few lab tests. No, you have to push it to its absolute breaking point. And that is exactly what a team of university students decided to do. And this is the International Moth. Now, this isn't just some sailboat. It's a hydrofoiling beast. People call it the Formula One of single-handed sailing for a reason. These things literally fly over the water on these super thin wings. They are incredibly sensitive to every little gram of weight and every tiny design choice, which makes them the absolute perfect and most unforgiving testbed for a new material like flax fiber. The scene is set at the SuMoth Challenge, a competition specifically designed to inspire this kind of radical thinking. The mission was simple: build a moth that is as sustainable as you possibly can. So enter the Audace sailing team from the University of Trieste. Their project? Bai-Flying Lina. And they weren't just there to participate. They were there to win. And this right here is what just blows my mind. This shows you how serious they were. The team didn't just, sprinkle in a little bit of flax for show. They engineered the single most critical parts of the boat, the hydrofoils that make the whole thing fly, so that more than half of their weight was flax fiber composite. This was a completely radical move that went against everything the industry considered standard practice. So we keep saying these boats fly, but what does that actually mean? And why is the material of those foils so incredibly important? Once you get this, you'll really appreciate the massive engineering puzzle these students had to solve. So this is a hydrofoil. The easiest way to think about it is like an airplane wing, but it's designed to work underwater. And that's a huge difference because water is about 800 times denser than air. That means the forces acting on this tiny wing are just immense, which demands a material that is unbelievably strong and stiff. It's really this beautiful dance of physics in action. As the boat starts moving, water rushes over that foil. Because of its curved shape, the water on top moves faster, creating lower pressure. That pressure difference creates this powerful upward lift. And once that lift is stronger than the boat's own weight, the entire hull lifts clear out of the water. Suddenly, almost all the drag just vanishes, and the boat takes off at these incredible speeds. It's amazing to watch. Okay, so you see the problem, right? Building one of these critical hydrofoils out of a plant-based material was a massive, massive challenge. You couldn't just swap carbon fiber for flax fiber and call it a day. No, they needed a much smarter, much more sophisticated way to design the whole thing. Their solution was an engineering strategy called multi-fidelity optimization. That sounds complicated, but the idea is actually pretty simple. It's a way to explore a huge number of design ideas without spending a ton of time or money on slow, expensive simulations. It's all about being really smart with your computer power. The best way to get your head around this is with an analogy. Imagine you have an idea. First, you might just sketch out a bunch of rough ideas on a napkin, right? They're quick, they're cheap, no big deal. Then you take your best 1 or 2 napkin sketches and you create a detailed blueprint. And only after you're sure the blueprint is solid do you spend the real time and money to build the actual prototype. And that's pretty much exactly what the team did, just with some seriously powerful software. They started with quick and dirty 2D and 3D models, the napkin sketches. Then they used a program to predict performance. That's the blueprint stage. But the real magic happened in step 3, where an optimization tool explored thousands of different design combinations all on its own. And only when the software found the absolute best candidates did the team run the really expensive, super detailed virtual tests, which are known as CFD, on just those top designs. And that's the key takeaway here. The sheer scale of it all. We're not talking about a human designer testing 10 or 20 ideas. The software systematically sifted through thousands of possibilities, hunting for that one perfect shape that could balance lift, drag, and strength for a hydrofoil made of flax. Now, all of this sounds amazing in theory, right? But there's only one test that really, truly matters. And that happens on the water. So the big question is, did this brilliant design process, built around a sustainable material, actually translate into real-world speed? First off, let's just take a moment to appreciate how fast they did this. The team went from a completely blank page to a finished, competitive boat in less than 8 months. I mean, that's just incredible. It's a huge testament to how efficient their design workflow was, and of course, the insane dedication of the students themselves. And here it is, the punchline, the final result. Not only did their flax fiber boat work, it won. This quote from the team's own research paper says it all. Their prototype wasn't just a cool science experiment. It was awarded the overall winner at the 2023 SuMoth Challenge. They proved, without a doubt, that a sustainably built boat could go out there and beat everyone. So what's the big picture here? What does all this mean? Well, this victory is so much more than just a trophy for a student team. It really could be a major turning point for the whole field of high-performance engineering. So let's break down the big takeaways. First, this project delivered hard, undeniable proof that sustainable materials can perform at the absolute highest level. It also completely shattered the myth that you have to choose between being fast and being green. You can be both. Plus, the design method they created can be used to solve all kinds of other complex engineering problems. It basically opens the door for the whole marine industry, and a lot of other industries too, to start taking materials like flax fiber very, very seriously. And all of this leaves us with one final, really exciting question. If a material made from a plant can win in the Formula One of sailing, where else could it compete? Think about it, from cars to airplanes to high-end sporting goods. The wall that has always separated high performance from sustainability, well, it just got knocked down. The race is on.